Yeah. All right. Good morning, everybody. Today I'm going to talk about SYRCL's upper watershed meadow restoration work. And shown on the map are all the meadows that we have worked on or are currently working on, which all are within the Yuba River watershed, which is outlined in purple here. Risa, the Bear Valley Meadow, is actually in the Bear River watershed. It's a little bit outside of our watershed. All right, so to go over a little bit of an outline of what we're going to cover today, I'm going to start out pretty basic and just describe, what meadows are and what meadow restoration is. And then we're going to talk a little bit about a project that we restored in 2018, the Loney Meadow project, which yielded some really neat results. And then we're going to dabble in our current and future work. Okay, so what is a meadow? I mean, I'm sure each of you can conjure up some image of what you think a meadow looks like, but to really describe like what makes a meadow, they're typically flat or even bowl-shaped environments. Often they're a valley and a mountainous environment, and when rain and snowmelt comes down off these steep adjacent hillsides, it brings with it both soil and water that, as those things enter this flat environment, typically slow down and deposit. So in a healthy meadow, stream channels are often meandering, moving really slowly and encouraging percolation or groundwater recharge. This supports a high groundwater table, which inherently supports wet meadow vegetation and herbaceous vegetation, which provides a lot of habitat for both amphibians and birds and also terrestrial species. Other benefits that healthy meadows provide are their biodiversity hotspots. They provide quality habitat, as I just mentioned. They promote groundwater recharge and flood attenuation. They improve downstream water quality, and they basically are able to delay our peak season flows. So in our dry summers, we receive flows later into the year. Meadows also have high carbon storage capacity. They're able to store up to 6 times as much carbon as adjacent forests. And they also provide refugia habitat in a changing climate. And this is really important as we enter prolonged periods of drought and rising temperatures, as we're already experiencing with climate change. So the benefits I just listed, it's important to note that these benefits are limited when a meadow is degraded or unhealthy, and up to 70% of meadows in Sierra Nevada are in a degraded state. When I say degraded, this illustration does a really good job of sort of contrasting the healthy meadow graphic we looked at, and these are provided by American Rivers. So as you can see in this degraded meadow, we see an incised stream channel. So that's something I'm going to say a lot, which is, you imagine like your incisor, your tooth that's sort of shaped narrow and kind of deep, if you will, in terms, if you imagine a stream channel, it's typically deep if it's incised. And so in this graphic of an unhealthy meadow, the stream flows or surface flows are confined to the single channel. They're not interacting with the floodplain. And so they're also moving pretty quickly. So they're not contributing to groundwater. And in fact, when a stream channel becomes this eroded and this downcut, it starts to pull the groundwater with it. And so the groundwater and the surface water are exiting a system really quickly, and it no longer can support the vegetation, which is what promotes carbon storage and provides habitat. So it's sort of a unraveling, if you will, or like a snowball effect once the meadow starts going downhill. To look at some real life examples, this is Van Norden Meadow, which has a lot of channel incision due to road impacts and grazing impacts. So I think this is Mary here is crouching down, and this is a culvert going under a road as a stream enters the meadow. And there's a lot of conifer encroachment in this meadow as well, since the groundwater table is low. So what is restoration? I pulled a little definition, which You can read here, it's basically the process of assisting the recovery of an ecosystem that's been degraded or damaged. And I like this kind of side view here of a degraded meadow versus a restored meadow in both winter and summer. And it does a good job of showing what I mean by like incised or downcut stream channel, shown here, where the flows just simply can't access the floodplain even when flows are high. And in a restored meadow, that stream channel is broad and wide. And so how do we achieve this? How do we transition a meadow from this incised channel to a broad channel that's connected to the floodplain? Well, there are a variety of tools kind of at our fingertips. And one is just a earthen plug, essentially just putting dirt in this at a few strategic locations to encourage flows to hit that plug, come up onto the surface and spread out and kind of slow down. The other option is to build a beaver dam analog, which is a kind of human-made, you know, trying to do the best they can to build something like a beaver. And that does essentially the same thing. It brings the water up onto the floodplain. And then lastly, in kind of systems that are really degraded, like Van Norden Meadow, you can do what's called a full channel fill, where you're filling a whole section of stream channel with dirt, hopefully local dirt, which we'll get to that in a second. Okay, so jumping right into an example of a meadow that we restored in 2018, Loney Meadow. We used earthen plugs and sedge mats in this meadow. And the historical use of this meadow was grazing. It was used pretty heavily for grazing. And if you look, if you can see my mouse here, the stream channel that's on the southern side where you see all the yellow dots, that stream channel is actually on much higher ground than the floodplain. So it's not normally where the water would have flowed. And it's believed that this was ditched intentionally by ranchers to encourage the water to leave the meadow quicker. It's actually pretty typical where meadows were seen as good grazing environments, and they were intentionally manipulated to become drier so that they can be used for forage. So to remedy this, we used a series of earthen plugs, and this is them in the picture. They're pretty low key. They aren't, you know, they've rebounded really well after a year, and that brought water up onto the surface, and we saw some really neat results. Here's a picture of Loney both before and after restoration in the same spot. It's also the same picture behind me because I love it so much. And you know, a picture speaks 1,000 words, but we really need more than that in our projects. We don't just stop at restoring. We really want to understand if we're meeting our project goals. And the project goals for Loney Meadow and also Van Norden and all our other meadow restoration projects are to reconnect the floodplain so that we can improve hydrologic and ecological function and ultimately enhance habitat and other benefits that the meadow can provide. So we measure the indicators of success by measuring a slew of different attributes, both before and after restoration. And we measure to see if we're seeing increased groundwater levels, if we're seeing a slower release of surface water, if we are experiencing an increase in wetland plant species, if we're getting an increase in carbon storage, and an increase in bird and aquatic species. So I'm going to jump into some results of just like what we found and if we indeed found that these things were true. But before that, I'm going to talk about why this meadow presented such a unique opportunity to see if we're truly achieving these results. So Loney Meadow is part of a meadow complex, which means there's two really close by meadows that are less than 2 miles away from one another. And Loney Meadow is shown here in this kind of pinkish purple. And we set up a multiple before-after control impact study design. I know that a few of you guys have heard me talk about this experiment many times, so bear with us. But this type of experimental design, it gives us power to separate the impacts that we're seeing, to be sure that those are from restoration and not from some sort of like wet or dry year or some sort of other kind of interannual variability. So in this experimental design, Loney Meadow is the treatment meadow, and we have our spatial controls, Upper Loney Meadow, which is just upstream, and Deer Meadow. And specifically, we'll be able to isolate the effects of our restoration on the hydrology, the plant communities, carbon stocks, and greenhouse gas flux. To talk a little more about how we studied these types of things, we began our study in 2015, and restoration occurred in 2018, and we continued through 2020 and actually are still sampling some of these things to date. In each of the meadows, we've set up a grid where we're sampling both plants and carbon and greenhouse gas flux. Then we have our groundwater wells shown in red on each of these meadows. And then lastly, and kind of one of my favorite things is that Upper Loney Meadow is a really nice control because it's upstream of Loney. And so we are able to, basically we have like a stream gauge upstream of Upper Loney and one in between Upper Loney and Loney and one downstream of Loney. And so this gives us a lot of really cool information, which we're going to get into soon. Okay, first we're going to jump into some groundwater results. We'll take it a little bit slow. So each of these points on the map are our groundwater wells. We have continuous data loggers and the ones in yellow. So those are what yield these really neat results that are constant data moving through time. A2 and A3 are the kind of first graph shown here. And what you see is that the groundwater has pretty, the seasonal patterns are pretty noteworthy before restoration, where in winter, the groundwater is close to the surface, but in the summer, it really dives down. And then as we get to restoration in 2018, the groundwater now is remaining much closer to the surface, especially on the A transect. On the B transect, we're seeing pretty similar results, which is here. And in the C transect, we're virtually seeing no change. And the C transect, as you can see, these wells are a little bit further from the stream channel. They're in a little bit higher ground. But we're also going to look at these groundwater effects now, comparing Loney, so the same graph you just saw, but looking at the control meadows underneath and just seeing that the control meadows provide some really neat information showing us that, you know, these changes are not due to the weather at the time. And I know those graphs are like a lot, like it's like, well, how do we know like what really happened? And we did do some math just to see like cumulatively, if we looked at the percent change of each of the groundwater wells. At Loney Meadow, we saw a total of 8% increase in groundwater. And at both of the control meadows, we saw a decrease over the same amount of time. So just kind of further gives us a little more support there. Okay, moving into surface water results, and if we're seeing a sort of regime shift in the surface water. So right now we're looking at the two stream gauges that straddle Loney Meadow, so upstream and downstream. And we're looking at the percent change in the amount of water that leaves the meadow compared to the amount of water that entered the meadow. And in black, we have pre-restoration. So as you can see, if you follow the black line from kind of October, the water that's leaving the meadow is basically the same as what's entering. And then we get a really big peak where a lot more water is leaving than entering in like late January. As you move through time, following just the black line, it kind of just peters out. About the same amount of water that's entering the meadow as leaving the meadow. If you compare this to the blue line, which is after restoration, you're seeing that it's below zero for all of fall, which basically means that the meadow is holding on to some water. Then this distinct crossover, which it's basically this method is used in the literature, and this distinct crossover really marks a shift in when the meadow is releasing its water. So it's releasing it later into the year after restoration, and then into the summer, a lot less water is leaving the meadow than is entering. And so that meadow is really holding on to that water. Again, we can look at our control, because you might say, well, are you sure? Like, how do you know? Are you really sure? And having the power of this control meadow is really neat. So now we're looking at the 2 gauges, upstream and downstream of Upper Loney. And we can really thank Carl for putting these gauges in. And also thank him for persistently creating graphics that I wanted him to make throughout the reporting of this project. So here, just looking at the black and blue line in terms of percent change, while there is slight, difference in the percent moving in and out, there is no distinct crossover in either direction. And if you flip back and forth with Loney, the restored meadow, that blue line is actually below. So it's flip-flopped even in the reference control meadow, Upper Loney. So again, just gives us a lot of confidence that what we're seeing is due to the restoration. Moving on to plants. This approach is a pretty heady statistical method, but in short, and keeping it kind of high level, the polygons or circles in the graphs, they represent the plant communities. And when the 2 circles overlap one another, that means there is no statistical difference or no change. And so Upper Loney Meadow, one of our controls, is in orange. In 2016 and 2019, they both overlap one another. So there's no change in the plant community in that control. There's also no significant change in Deer Meadow, which are the 2 green circles, which overlap one another. But in Loney Meadow, we have 2 circles that have absolutely no overlap. And in 2019, after restoration, that plant community is shifting towards Upper Loney in space. So again, this is just a really convincing result that we're seeing a shift in plant communities. Now to talk about carbon storage. I could literally do a whole talk about this, but I just selected one graph to keep it short. And this box plot shows that in our treatment or restored meadow, we have a significant increase in soil carbon, which represents carbon storage. We do not see significant changes in either of the control meadows. So to summarize, we saw some really neat results in this experimental setup. And we got pretty excited because what this means is that, restoration tools have the capacity to really increase benefits in meadows. And now, as we're starting a huge project in Van Noorden Meadow, we have the opportunity to see these benefits at a much larger scale. Okay, so Van Noorden Meadow is a project I know y'all heard me talk about a lot. It's a 485-acre meadow. It is the biggest meadow in the Yuba River watershed. It is one of the biggest meadows on the western slopes of the northern Sierra Nevada. It is 10 times as big as Loney Meadow, and so it's a really big deal. This is the picture of it from kind of high up, which shows kind of its beauty. And it's located pretty close to Donner Lake, and it's in both Placer and Nevada counties. And we're doing a really big restoration project at this meadow. As I spoke about before, in a highly degraded system, one might want to use a full channel fill approach, especially if there is a local fill source. Well, luckily at some point, fortunately or unfortunately, people installed an earthen dam berm at this meadow that's almost a mile long. It's shown kind of down here. This meadow was used to harvest ice in the 1800s, and there was a dam that created a reservoir that has been slowly notched over the years, and currently there's a spillway, but the wings of the dam berm are no longer being used. So that gives us a big source of material that we're going to then use to put into the channel to bring the bed of the channel up closer to the floodplain, so that when flows enter the meadow, they're encouraged to spread out and across, and they're really going to slow down. We're also doing beaver dam analogs on Castle Creek, which is this stream channel right here. We're adding beaver dam analogs there. We are repairing the road, the county road. All the culverts will be replaced or repaired. We have a series of culverts we're putting in here at the Lytton Creek fan to encourage the water to be able to spread out as it enters the meadow. We have road improvements on the Meadow Bisect Road, a bridge replacement, and also up to 125 acres of conifer removal or thinning. So pretty exciting. That's what we'll be starting this summer. We also have 3 meadows that we're working on in the North Yuba that total 131 acres. It's the Haskell Peak Meadows project. And these meadows are, I'd say they're kind of in mediocre condition. They're definitely degraded, but they're not nearly as in as poor condition as Van Norden Meadow. So we're using like low impact tools for these 3 meadows. And we're doing beaver dam analogs. And here are some examples of BDAs that the contractor that we're hiring has built in other systems. And yeah, they're a really neat tool, and I'm excited to work with these more going forward. And with that, I'd like to thank our partners and see if you guys have any questions.
If we wanted to go up, Alecia, and see the work or see the meadow, what's the best way to get there? It looks like on Donner Pass Road.
To Van Norden.
I mean, yes.
Yeah. So Soda Springs Road coming, if you exit like you're going to Sugar Bowl.
Yeah.
If you take that exit, you take a right, and then you take a right onto Soda Springs Road. Then you'll cross some railroad tracks and you'll take a left to enter the meadow. It's kind of inconspicuous. There's this really huge parking lot. It's like a big dirt parking lot. It's like, what is this place? And then if you keep going down a road, then you'll just see the meadow all on your right. It's kind of hard to see too because of how many conifers have encroached. And that's something we're really excited about, is to really open up the viewing of the meadow. Just, you'll be able to see it from everywhere once we're done.
Nice.
Yeah.
Thank you.
No questions. I didn't throw a ton of information at you guys. Maybe it's just too overwhelming.
It was amazing. And I feel like you made it really digestible for sure.
Yes.
Oh, good.
And really stoked, having been here for 5 years and seeing what the control showed you.
Yeah, and we're still like we measured plants again last year, and we're still monitoring groundwater on a monthly basis in the snow-free months, because we're really curious, like, you know, what about in a really prolonged drought like we're in right now? Are we still seeing benefits, and what do those look like? So it's a neat opportunity.
Well, and aren't you still doing a project at Loney, like the bridge possibly? The work is still happening? Yeah,
I had a meeting about that yesterday. Yeah, we're hoping to install a bridge this fall if the Forest Service can do it in time.
Alecia, this is Kat. I have a question.
Hey.
I'm sorry if you mentioned this, but is there total like cattle exclusion here? Is there any presence of grazing activity or anything like that that's impacting this too?
Yeah, so that's a really, really great question. So at Van Norden Meadow, they're no longer grazing, but it used to be grazed by like thousands of head of sheep, which is why one reason it's in such poor condition. At Loney Meadow, there is still cattle that graze that meadow, which is why we like fence the aspen, and we still fence our downstream grade control just in case. And we also fence our groundwater wells because they damage stuff. But it's a very managed, I think it's 100 total, and they have a pretty large area to graze. So they go to Deer Meadow, Upper Loney, and Loney. And so I feel that the degradation was done by ditching and then having a really dense herd. And so what they have now is, I think, pretty sustainable, especially because as it gets wetter and wetter, they don't really like to go into super wet areas. They'll stay kind of a little more on the edge, and they have a lot more stuff to get into, maybe the aspen, which is why we started fencing those. So it's kind of it's real life, right? Like, there are multiple uses for this meadow. We don't live in a vacuum. And so I think managing in a way that there are, sparser cattle is our main option here. But in the Haskell Peak project, those meadows are pretty heavily grazed by sheep, and it's a problem. Like, it's something that the Forest Service has been kind of starting to recognize in recent years. Like Luke and our former hydrologist contact there was just like, it's really bad. Like they're really compacting and affecting the meadows in a way that's not sustainable. And they've done a lot of historic damage. So kind of 3 different scenarios in all our projects, but we're hoping to push towards like sustainable grazing.
Interesting. Yeah, it seems like a lot to navigate if it's different at every site. Is there, and this is like a much bigger question, but is there any potential for real beaver to be in the picture at some point?
I hope so. Yeah, it's been talked about a lot. It's like, apparently it's pretty complicated, but I mean, I think in a direction where, yeah, especially in these remote meadows where the beaver aren't going to be affecting someone's land. So I think CDFW will come around. Might be 10 years.
Yeah. Cool. Interesting. Thank you.
Oh, and Van Norden has had beavers before, so we think they're going to show up naturally.
That was my question. I was wondering if like there are beavers in other like outlying areas near any of the meadows that, they may just start moving. I don't know if they're tracked at all, like in
yeah. And Van Norden there are, and these others they're not, because they're just like extirpated at such a high rate, unfortunately. And they don't have a very clear path. But in Van Norden, because it's close to the Tahoe Basin, we'll get some.
Thanks, Alecia. That was fantastic. I'm gonna